All right, we're live streaming now, guys. All right, there we go.
Hi,
I am good. Assalamu alaikum. How are you? Let me come on video.
Yeah.
How are you doing?
I'm doing good. I'm doing good. Hey, Maher,
so this is we're live streaming. Wait, just saying, we're recording live streaming to YouTube, Shield Vision, and so I just want to, let's get people up. Yeah. So everybody it's open source, right? So this is for the community, and
it's like just the two of us right now, right?
It's just the two of us. So let's I think we share this link with people that we know, then they could come in here into this meeting and join us. And I'll make you the co-host right now, right?
Okay, good. Let me share it with
other people.
Let me share it with Rajat,
yes,
okay?
Yes. Yeah, of course. Yeah, Rajat's gonna be all over this, and Rajesh, so it's like all the other guys in there. And I'm pretty sure, let me see. Once other people come in, we'll make some of the co-hosts.
Okay.
And it'll take some.
I'll also make Qaradan the co-host.
Yes.
Qaradan also, so he can join in. There you go.
Yeah.
Okay.
Yeah.
Anyway, so there he is.
This should be a lot of fun.
Yeah. Here's our brain here. Okay.
Yeah. So everybody's kind of logging in. You guys can log into the Zoom. Did you see the Zoom meeting in the Pillar Tribes? Hold on. We're live.
Okay, so Maya.
Yes. Hold on. Let me just tell everybody what we're doing. OxiKit troubleshooting, OxiKit open source, live open source troubleshooting, India and Afghanistan. And
so Maya, let me tell. Can we talk now? Okay, let me tell you what's happening.
Wait, hold on. Let me do this. That way we don't repeat ourselves. Let me tell other people about what's going on. Let me just get this Zoom link started to roll, right? So the other please join us. Techies, please join me.
Okay.
Yeah. I mean, you know, we just tell people this is what's up. These are the builders. So basically tell the different groups, hey, we're in here, and that way we don't repeat ourselves, and then people are going to start coming in.
Yeah.
I think. And we're definitely like just hitting them at a what's that word I'm looking for? Pretty let them log in and give them a chance. But while they're doing it, how about this? Let me show you where I'm set up. Yeah, see Karan, okay, admit. Hello, Karan, you there?
Yes.
Okay.
Hi, Karan.
Hey, hi, Meher.
Hey, how you doing?
Great here.
All right, hold on.
Okay.
I'm missing that stag work over there.
Yeah. Oh, nice. Yeah. Oh, yeah.
Yeah, very eager to visit there, but unfortunately, I'm at Pune, and that's around I don't know, like 500 kilometers, something like far from here.
Yeah.
But great job there. Good going.
Oh, thank you, man. Can you help us out with we got some troubleshooting. Hold on a second.
Okay.
Hold on, I'm texting.
Чисто дійсно якась часть
Okay, here we go. Yay! We got more coming. Again, more folks join in here. Have you guys the meeting, the Zoom?
Yeah, searching food for you guys.
Okay.
Yeah, in some other mission.
Rajesh is in here. There we go. All right, cool. So they're starting to come in.
देखो इसने हगना शुरू कर दिया है मेहर ने
Hey, Rajesh. Hey, Rajesh, I'm making you co-host.
Hey Meher, I just woke up. Just give me 20 minutes.
Okay, well, yeah, well,
Hey
well
Rafat,
you can.
how things are going on?
Hi,
Thank you for
Brajesh.
your
How are you doing?
You were very helpful. So thank you, Rafat.
Yes. How are you doing,
Well,
Brajesh?
I'm good.
Good.
Well, he's having Rafat, he's having sorry, Rajesh, Rafat's having some issues. We're having some issues, some code issues. So we're basically just talking about it now, right? And we just put out to the group that's what we're doing, and we're just gonna do it. Right? I've got the so here. Let me show you what's going on here. Let me flip my screen. Okay. Screen. There we go. All right, you guys can see here's what's going on, right? So I've got a vacuum cleaner here. I've designed a noodle. I got a loader about to go in here, and then we've got our bunch of sieves. You know, I prepared these to load up, and I was having the issues that your guys are facing there too. So we had like 19.5 from the bottom to the top here, right? 19, 18.5s, right? I even went and we were basically labeling these guys like this is green for green electrostatic filter, which is this guy. And then if Rafat, you can maybe let people in, or who can, if you can make somebody co-host to let people in as we talk, you know.
Yeah, I'm doing.
So I'll show you. Yeah, so I'll show you kind of the structure I have going on here, and then you can kind of like show what you got going on over there, and we'll just kind of go through things, because I was about to basically load up the sieves, you know, but if you've already had an issue, then maybe we
Okay, you're breaking up a little bit. So
and got these preloaded.
Your voice is breaking, I guess. I'm the only one who is facing this problem.
Yeah. Your voice is breaking up, Maher. So I think maybe you went to a place where your reception is weak. Okay, so we lost him. He'll come back. Hi, Stanley. You just came in. Maher got disconnected, so he's come. We're waiting for him to come back. There he is. He's back. Maher, you're mute.
All right, there. Can we hear now?
Yeah. Now you can hear me.
You can hear me now. All right.
Yes.
Here we go. We're live streaming. All right, there we go. So, by the way, I want to introduce. Can you please? He's letting us so gracefully letting us use his factory here. This is, you know what? I'm gonna let him do the honors and go ahead and introduce yourself, sir.
I'm Rakesh. I'm the chairman of SLAG International, and we are proud to have our lovely friend from US with us and working on the oximeter, oxygen concentrators. Thank you so much.
Thank you, Mr. Rakesh. Right, so we're using his facility here over at STAG, and he's the German and Vivek's brother here, and we're about to go live and show the world the truth, I guess, as it happens, you know. And he's having some issues, we are too. Thank you, Rakesh, very much. All right, so here we go. So yeah, there's more people, guys. Okay, so here we start. I don't know where we lost at, so I'm gonna kind of start to tell you where the position I'm in, and then where you're at. And also bear with me that I haven't had any sleep at all last night. Again, I built all this stuff last night with you guys, right? So we've basically built different sieves here, different lengths. We got 18.5, 18.5, 19, 19 and a half, 19 and a half. They're 3-inch in diameter and measured up to the very base to the top. And there's the filter at the bottom, which is basically one of these guys here, right? The drain cover, as we, that's it. What's at the bottom there. We did put another filter at the top, another screen at the top down there. And then we're gonna fill it with zeolite and cover it. The bottom, by the way, because this does make a difference, we noticed, are basically curved bottoms, right? So you have either flat bottoms or you're gonna have curved bottoms, right? So these are flat bottom, these are 1/2-inch holes. And I've got some, we've got PVC pipe. This is really, really helpful. Okay, these things are super duper helpful. These chains that basically allow the ability to kind of access the pipe very rapidly and quickly, and lock into it, right? Hello. And then we got some surge tanks pre-built. Here's our springs that we're sending out. We have 2 types of vent filters for the front, right, that we're utilizing. So we have one that's an electrostatic filter, another one that is a fluid style filter. I don't think this one's electrostatic. You guys, Apache there? Hello?
So بخش ماده اینجا امروز این گروپ OxiKit در چیستم بخاطر از این مشکل برای بیرون که چی اگه چیز میشه
Can you hear me?
Okay, Maher, are you?
Can you hear me?
Yes, I can hear you. Yeah, yeah.
All right, so
Okay,
basically,
let me tell you.
you tell me the problems
Yeah,
you're having, because we're having issues here, right? We're gonna go through it. So I'm
yes.
just kind of showing you the setup we have. Can you show us the setup that you have over there? Basically, show us the setup you have and the issues you're having with the machine, and that's in there. You know?
Actually, I cannot show you the full setup because it's in the factory and I'm in the office right now and I'm connected through the computer, not through my phone. But
Okay.
we just took a video. We just took a video, so I will share that video with you. Okay.
Okay.
Let me just do this. And now let me just play this video. So do you see the video?
Yes.
It's still. So, so basically what happens is that here are the two sieves, A and B. And as you can see, they're not timed well with each other. So for some reason, they don't load up. Let me just shut down the noise, sorry. Let me shut down the noise here, there you go. So you can see here, this one is going down to about 10. It doesn't go all the way down. And this one goes now to 0. And the other one goes to just under 30, but this one, stays at around, 10. So you can see that, there is this challenge. It doesn't go all the way down to 0. And the result is that we are getting about 55%, but no more than that. So, we have had other problems and we were able to resolve that. So right now it shows 36% here, but it will go up depending on certain circumstances. Now, this guy here has a calibration issue, so it doesn't go all the way down to 0. So that means that even when it pumps up to about 25. It doesn't go all the way to 30.
And so let's talk about, I guess let's go through the steps here. Because we're getting similar, we got into the 80s here when we were running over here, and I think that's at 17.5 sieves, 17.5-inch sieves that we were using. One of the guys that came over, Perret, I think his name was, has told us that to use 18.5-inch is what he used when he measured it, and then that was the length that would get the better results. And he actually hit 29 with higher results. So I'm gonna try to get him to jump in here and help, because he has actually had the most kind of success.
What's the height of the sieve? Yeah, we have 17 inches. So our height is 17 inches.
Yes. So I think that we need to go to, that's what he told me. He said, and then as far as the timing, did you play around with it? Did you have a chance to play around with the timing at all?
No, we are not very familiar with programming, so we didn't mess around with the timing. So if we can get some guidance, we might be able to do some work with the timing.
Yes.
Right now we're at 5-second cycles. So if you stop,
Okay, I was just basically looking around. Okay, so if you're there, I sent you. If you saw the WhatsApp message, I think I sent you. There's like a ratio you want to follow, right? So if you're doing basically, if you charge the tank more, like longer cycles, like 5 seconds, 6 seconds, something like that, right? Then, well, first of all, then you could get higher output, right? But if you charge it less, right? If you charge it less, like 3 seconds, 3 seconds, 3.5 seconds or so, then as you're doing the cycle adjustments, at a smaller cycle count, you won't have as many issues, but you'll get a lower LPM output. But you can still, you basically have to play around with it. Is it 3, 4, 5? What is that magic kind of number in which will allow? Hold on a second, if we can just. Okay, all right. Yeah, and then it's like, what's that magic number? And I noticed when I was doing this, with different, it'll actually, you can like 1 second 1/110th of a second can make a big a difference, right? So it's almost like a per sieve thing. So being pretty precise is important. So when you say 17 and a half, do you know how you guys did you vibrate the sieves at all?
Yeah, we did. Yeah.
You did in your system.
Yeah.
Okay.
Yeah.
All right, and then
well, we didn't vibrate it with the vibrator. We vibrated with the hammer. So hit until it wasn't going any. It wasn't compacting anymore. So.
Okay. So we have a.
Master
So what we've done is, let me kind of
मेरे को लगता है
share.
थोड़े से फॉलोअर और बढ़ा ले फिर फॉलो कर ताकि फॉलो बैक ज्यादा मिले क्योंकि उनको लगेगा तो अभी नए नए आदमी फोन करे
Can you mute your mic?
Yeah, please. Yeah, guys, if you're coming in. Yeah.
Okay, good. Sure.
So now I'm going to flip the screen here. Right? So, Vivek had a great idea, which was he basically got this platform, right? A exercising machine, which is it vibrates, and that's what we were using. That you can adjust the frequency and the hertz here, and that's a cool tool. So we also had another. Ed created this, which is a vibrating. You put this on top of it. This is what we're gonna put the sieve in. You put this in here. You put this on top of a table. A tire. You can use a concrete vibrator, and that will vibrate the sieve as well. So I'll kind of actually start to load up the sieve and kind of show how we do this, right? Because this is definitely important, So can maybe can we get some help, Pavan? Oh. Hey guys, can you hold the phone? Well, I don't know what everybody. Can you hold the phone while we load up the sieve? Yeah. Hold on 1 second. Let me find out where we're back. Give me 1 second. Yeah. Okay. So let's go ahead and I guess the sieve here this is the 18 and a half, and I've labeled it. And by the way, we've got inventory in there for other folks that have ordered, loaded up with bags for them to send them out their orders. And, I want to make sure that we're going to, hopefully get a better live answer here on what's going to happen. So one thing we're going to do, one thing I did here also is, I'm just going to basically live work is what we're doing. If we have a hole at the bottom here, okay. One thing I did with this machine is I drilled a hole right here. Okay. So by doing so,
Brother Meher, I'm so sorry to interrupt you on middle.
Yes.
If someone can do a video recording, I think it will be helpful. You can share this recording to someone like to the group, so they may not.
Okay, it's recording. Yeah, I saw it.
It is. Yeah. Oh, okay. Yeah. Okay. Great. Oh, it was paused. Okay. Great. Yeah. So yeah, we're recording and we're also live streaming right now to YouTube. So if somebody could check that, that would be helpful, right?
Yes.
So yeah. So here we go. Actually, you know what? Before I even get started here with the zeolite completely, and I'm doing this on purpose, guys. Okay. Like basically, it's like, okay, this isn't like a perfect environment. Why am I doing it this way and not in the factory? Because this is what people are doing at home. Okay, they're doing a DIY style kind of thing. I've been watching people, right? So I'm just being completely like hacking. Here in India they call it jugaad, right? I've been up all night. If you look back here, if you're just joining in, we've been basically working and setting up to fill sieves, right? And so this is what it looks like, right? When people are basically up working nonstop. A lot of us are doing this, and Rafat and his team, I'm sure over there, and the guys in India over here, Vivek just stays up like nonstop, and so there's a lot of the other Indian folks over here, and like, we've got the factory manager, whether it's Pavan or we had the chairman, we had Vivek, we've got like 100+ employees in here that have been really helpful. The city of Meerut has welcomed us in to do this here. I mean, it's a global project. We've been doing this for over a year, but this is what it's like, right? It's basically hard. It's not easy. It's not easy, and so right now I'm just on the fly. Hey guys, if you're coming in, and please go on mute. Hey, can you mute them, Rafat, while we do this? Yeah. So what we're doing here is I'm literally showing you guys I'm also kind of showing you a little bit about what it's like for me here too, like this is really what it's like. It's not some glamorous stuff, right? I'm sitting here punching holes into this foam thing. And what I'm doing here is I'm creating a channel, okay? So that we can have I'm basically creating a template right now. This idea just kind of came in. So that when I pop a sieve in, I don't have to connect the tube to the bottom and the fitting. I could pop it in open, and then I can basically use vacuum suction in order to pull the zeolite down, because you want to compact the zeolite, right? Whenever it's in there. And the reason you'd want to compact it, and you vibrate the system, and the pellet sizes matter. Maybe I'll draw on here why I think that is, at least. I'm kind of giving just a live tap stream. This is what it's like, guys. This is a DIY, not perfect solution. I'm being real here, okay? Because it's important I disclose that this is an open source project, and this is what it's like for a lot of people. And I'm here in India, right? And I'm doing this. And this is what it's like for any builder in any garage, pretty much, that's doing this for the public. Am I still on? Can you hear me? Am I still there? You can add, but can you get? Yeah. Rafat, if you can just add whoever's in the waiting list, that'd be helpful.
Yeah. I have.
Okay.
We're all in here. Don't worry.
Okay. So by doing this, whatever it is I'm doing right now, may whatever faith or religion, there's all this stuff, but we're all human beings from around the planet, whether we're here in India, and I learned a lot. While I'm talking, I'm just going to kind of mention, I learned a lot about Burma here. There's actually, India is a very interesting place. They have 27 major languages here, right? It's like a world. It's like a country. So imagine a world with a bunch of countries in it. That's what it's really like. Most people don't know that. I lived here for a while, but so diverse, so ancient, historic. I should love this place. Meerut is probably my really. I love the city. I fell in love with it because it's so industrious, and the reason I fell in love with it was looking out the window. Just by looking out the window, I looked at, it looks like India everywhere you look for the Indians here, but as an outsider, as an American, I saw the loads on the trucks and the motorcycles going by. And they're all builders, and everybody's shut down. And it's hard for people to live right now, and struggling, and yeah, this is a very emotional project for me. All right, so we're gonna go ahead and build the zeolite, see what happens, and may God bless this for the planet, so people can stop suffocating to death. So this is a sieve, and it's 18.5 inches from the bottom to the top. And we're gonna go ahead and get in here now. We'll get some help over here, guys. I know this was just on the fly. You know, it was like this session that's starting up right now. It happened, you know, calling. I mean, we've been having issues. I'm like, hey, let's just do it. You know, it's open source. We're gonna just talk about it. You know, about everything. Let's do this. So let's get a funnel in here. So now I gotta find a funnel, right? And like, this is what it's like when you're a builder, I guess, by yourself doing some stuff. No funnel, right? So I don't know where it is. I've been out for a long time. So go ahead.
Maher,
go straight into it.
Maher, can I interject here?
Yeah.
So let's talk about you know how you know what kind of problems we're facing. And in our case, we have a timing issue with the software probably. We have the you know, as I showed in the video before, we have one of the sieves not going down to 0 and also not reaching capacity of 30 psi, even though on the compressor we're getting.
Well, that's because I think you're based on the feedback that I got was you need a larger sieve, you know. And so I think if we just go through this, because if you look at this machine here, look here, we're rigged up, right? So we can at least get
what kind of length do you have for the sieve here on this machine?
This is it has the same. I mean, we have the same exact issue you're having, right? So I got a 17.5 inch sieve from here to the top, right? So, but I remember Firat told me that it has to be 18 and a half, right? You said 18 and a half is the magic number to hit the higher deals. And I was like, wait, with this, we've been doing 17 and a half. He's like, yeah, but and actually he has four and he has bigger sieves for some bigger numbers. But I was like, okay, well now this is why I went ahead and preloaded.
So the one who said that 18 and a half is the right number, and did he hit 95%?
Yeah, he showed the numbers. Yeah, 90, that's what he told me. He showed me the data. He hit 95% here. Let me turn this around here for a second so I can talk to see if I've sent him. I think I sent him a message. I sent him to come in. Let's see on top. Please join us. Okay, so I'm asking him to come in right now. Let me connect you with him as well. Well, he's in a group, by the way, right? So, you know, the private one, I'm going to go ahead and mention in there if he can come. We also have hey guys, anybody here? I mean, if they could just kind of, honestly, I'm getting this started, really, you know, and what I'd like to do, because it's a live Zoom open source thing, and I've been doing this for like the last year, is pass this over, like Suraj and
brother
Meher, you know,
Mr. Raptaj Ludin, sir, he's asking the timing issue. So
yes,
can we help out the timing?
Yeah, I know, but that's what I'm saying.
Yeah.
That's what I'm saying. Like, guys, I'm tired, man. I'm really tired, dude.
Okay.
Like if y'all can
you now?
Yeah.
Yeah, just hold on a second, Maher. Let Suraj talk. So, Suraj, go ahead.
Yes, please.
Yeah. May I know, are you using the Arduino or are you using a kind of some PCB that made by you?
No, Arduino. We are using Arduino.
Okay. What is the time you have set it? Like what was the timing you so far you have put it?
So the timing, we have used a standard software download from
I know.
From
I know that.
OxiKit site, and it's about 5 seconds. It's about 5
Correct.
seconds, right?
Okay. Yes, Lalit sir, please go ahead.
Rafat sir, hello.
Yes.
I'm Vijay from India, friend of Meher sir and Suraj and Brijesh sir. So can you change the time from 5 to 7 seconds?
We are challenged with sorry, we are challenged with programming. So we don't know how to change. We don't know how to change the timing.
Okay. We have in our team with Meher sir, Dr. Manu Prakash. So he's a software engineer. He does all these coding things from us. And whosoever has done for you for Arduino could change the timing. The timing means you have used 5,000 milliseconds. From 5,000 milliseconds to 7,000 milliseconds you can try. And then there is a hold time also.
Lalit sir.
Yeah.
Can we help Rafat sir? Do you have a team viewer in your laptop?
We
can do it from here.
Yeah.
Yeah, we could set up something. We could set up something. So
yeah, if you have a team viewer, me and Lalit sir, we can do that, sir. If you have a team viewer in your laptop.
Okay, let me see. Team viewer. Is that Microsoft Teams? Is that what you're talking about?
No, I will. Can you say hi in my WhatsApp? I can send you the link.
Okay, good. I'll do that.
Yeah, please do that.
Okay, and your WhatsApp? Do I have your number? WhatsApp number?
Just wait. I will say hi to you in WhatsApp. 1 minute, please.
Okay, good.
Just 1 minute. Got it?
Yes, Suraj. Yes.
Yeah.
Sorry about that.
So I will just share with you the link. Okay, 1 minute, please.
Yeah.
1 minute.
Pardon sir. The team viewer میخواد نشان بده برای ما چه رقمی تایمینگش چه پس تبلیغ کنیم. میشه که داشتی تو بریم برای شما داون میکنم رو. نخیر بسیار بخشم بخاطر از اینکه از اکسیژن است از موضوع اکسیژن چیز سک بی جنجال شده بخاطر از اینکه تایمینگش آف است اینا باید تایمینگش رو تغییر بده. باشین که روان کنم برام باز براتون داون. Okay, team viewer.
Can you download this one, please?
Yes. 1 second.
Yeah.
یه باتون داون میکنم شما دانلود کنید خود از ری راون کنید. Okay.
Hey, Suraj, if you could come on video, man, and that'd be great, dude. Like, if you could relieve me a little bit of some, I could just sit back and you kind of help. You know this in and out. Like, you're the guy, So, can you do that for the world?
چیز یک تایم ویوره کلیک کنین شه باز کنین اونجا نشته است دانلود. اینو دانلود کنین بالا.
Suraj?
Yes.
Do you think you could come on video, man? Is that okay?
Yeah, sure. Yeah. Actually, I'm at home. My health was not very good because last night I came very late. So yes,
no
I
problem.
can come on video.
No problem if come on video.
Okay, sure.
Yeah.
No problem. Yeah, no problem.
Yeah, Suraj, these guys, we're surrounded by a bunch of like angels here in India, man. These guys, like Suraj and all these guys here. Let me show you. Like many of them have been working real hard. You know, before we get real, like, yeah, Suraj, yeah.
Oh yes, yes, I remember. Yes. Yeah, he's very strong working person. Yeah.
Yes. Hold on, let me put him on here. You know, there you go.
What's the temperature in India? In Delhi or in India? Is it like?
Things are a little bit better.
Yeah.
Real hot. yeah. We're pretty much the same as you are here, right? It's and then here's Pavan, even the factory. Yeah. Hey, say hi.
This is from Stack.
Yeah.
Yeah, I'm sorry, but this is taking some time. It's taking some time because our internet is not as fast as it should be.
No problem, sir. No problem. We will be here to help you, sir. Don't worry.
Yeah.
I'm gonna go ahead and go on mute. You know, you got Suraj there that's helping. I just want to do he'll help out, guys. He's the service man. And Suraj, while they're getting set up over there, can you kind of maybe introduce yourself? Because we're recording and we're live streaming to a lot of folks. So enjoy yourself. It'd be helpful.
So Rafat sir, when your downloading is done, just let me know so that I can on my.
Okay. Yeah, this is very slow. This is moving very slow. It says it says about 40 minutes left. So this is gonna take a long time.
No. It will take only 5 minutes, I think.
Suraj sir.
Yes.
Suraj sir.
Yes.
There should be equalization time should also be there, no? At least 20% of the total time.
So before I'm doing, I will let you know. I will show you in the picture so you can tell me. Okay.
Yeah.
And guys, like
using Arduino.
Sorry.
Yes, we're using Arduino. Yes.
Okay.
Yes. You download now? Okay. Hi, Vivek. I'm doing good. How are you?
There he is.
I am at the back end. I'm not very technical, but yeah, I think I'm there to support all the way. So I hope this is happening soon, and there's another. All of them are helping to get to the right set so that we can have a workable machine very soon. So
I hope so too. Open a screen, but the Chiburin, the Zoom login can purpose. So Suraj, it's downloaded now. So it's downloaded not on my computer but on my colleague's computer. So on mine it's still taking its time, but on his computer it's already downloaded. So he's right here. He's logging in a second.
Can I see the screen?
Yeah, give me 1 second.
Okay.
I'm gonna open kare. Login kare. Yeah, the Zoom be. Oh, should have caught me. چرا پتا در افغانستان در پای آدم میره هر جایی. Sorry.
So Raptal sir, when you download this TeamViewer, once you open, and then it will open like this. Can you see that?
Okay, so he just logged in, so he's now on Zoom with us. Can you share your screen? So when you open it. رقم ميوت شبكة رقم مش ممكن يدخل خارج.
Please share your screen.
Surya sir, also try to find from sir that how much quantity of zeolite they are using in each sieve bed.
Yeah, Raptal sir, what is the quantity of zeolite and what is the height of the module?
Hello, Rafat sir. Hello.
Yeah, it's 17 inch. Yeah, the height is 17 inches, and
Okay.
the quantity of zeolite is how much? Zeolite. So we have 3 kilos, just under 3 kilos, just under 3 kilos.
Under 3
Fine.
kilos. Okay.
Okay. So which zeolite are you using? Sodium base or lithium base?
Yes, sodium based.
Sodium based. Okay.
Okay.
Wait, please. I want to do this. Yeah, middle one.
Yeah. No, I'm out. Awesome. You need to share. You need to share your screen again. Yeah, just go again. Share.
So when you open this TeamViewer, give me this ID.
Yeah.
Okay, coming. Okay.
Yeah, ID रहा कम ID रहा. Okay. I'm ID number شبكة ده.
No, go to the desktop, sir. You please go to the desktop. There will be icon called. See, listen. Also, you can you see this TeamViewer? Can you see this one?
Yes.
Can you see this one? Yeah, this kind of logo will be there. Can you close this? Can you minimize this one, please?
In the desktop. Okay, so your ID is this number. So do you see the ID number? 167 153.
We also need to check the outlet of oxygen coming out from a sieve bed. The pipe connections also should be checked.
Okay. Sure.
Adnan sir, you need to share this screen. I need to see. Okay, do you see this now?
Yes.
1 second.
Wait, please wait, just wait. But I'm not able to see your partner ID.
No, you have to write there the partner ID.
Acha, acha.
You guys hear me?
167153042.
Okay, fine. Okay, I got it.
Yeah.
Hey, just so you guys know, real quick. Hey, while you guys hear me? Or not?
Yes, I can hear.
Okay, y'all continue. Okay, this is kind of for the other people recording. See your different screens, but if like what we're doing here is, I'm gonna go ahead and just fill the sieves and stuff while you guys are talking and getting rolling, which is first time type stuff with plan. Oh, there we go. You're right.
Okay.
So basically, just by vibrating, guys, we were all the way up at the top, and then it went all the way down here, right? So we're talking about like a difference of like that much, right? Like that much difference, which is about. I mean, it's in the video. You can see it. This is at least 3 inches. 3-4 inches. We need to put more.
Go down.
Okay, Suraj, were you able to get in?
Yes, just wait 1 minute. Yes. Okay.
I will let you be with Khalid on his. He has his computer, so he will be able to work with you on it now. Yeah.
The password is KPV72D9K. Yeah, I got that. So where is the software right now? Where is that? Rafael, sir? Can you hear me?
Hello, Rafat, sir.
Yes, I can hear you. I can hear.
Yeah. Where is the software you are using? The Arduino software in your screen?
Khalid, sir, can you bring the Arduino software on your screen? Yeah, and then share that.
Okay, just wait. Yeah, just wait, please.
Yeah.
Just wait, okay, Lalit sir.
Yeah, I'm able to see.
Yes. Can you just see and guide me where to edit?
Yeah. Let me go through because
Okay,
this
please.
is done little differently. Save as save to.
Nafar access داره بچه تا اسکرین تا نمیتونه.
Yeah, I can see production delay. So this is 4 seconds, and then startup pulse delay is 1 second. Flash delay is 4. 0.45 second, and pre-charge delay 700 milliseconds. Okay. Hmm. Anything below to that? Hello.
Rafael sir.
Rafat sir. Anything below to that?
Below which one?
Yeah. The set delay timing below that. Yeah. Yeah. Just hold on. Just hold on. Okay. What I would suggest, sir, Surya sir.
Yes.
From 4,000 milliseconds, they can make it 6,000 milliseconds. Yeah, this one.
This one?
Yep.
Okay.
Rest of the things are fine. Only this one you make it 6,000 and then send to the Arduino. Yeah, that's all. And then ask the engineer to do the he can send from above top. The up
This
arrow
one?
is there, yeah.
Kaun sa? Okay. Verify?
Yeah, verify. First you verify.
Okay.
And then ask him, is the Arduino board connected with the PC?
Not right now, but
please connect. Please connect.
Can you please?
Is there any engineer?
We have an engineer, electrical engineer.
Yeah. So just simply ask him to transport this code to the Arduino and function it. That's all.
Yes. Okay. So we'll do that.
He might be knowing how to do.
Yeah, he knows. He has done it before.
Yeah. Please.
So basically, what we'll do is we will adjust the timing.
Yes, that's all. That's all.
Production delay. Yeah.
Yes,
is it just
delay,
one or there are two? Is it just one or there are multiple ones?
It's for both. The production timing it will now get changed to 6 seconds.
Okay, 6 seconds, and then if it doesn't work, then we can go to 7 seconds, right?
Yeah, that is also there, and yeah. For first, you check with this how this is affecting the purity. Yeah.
Okay, good. Okay, wonderful. Well, we will try.
They were also having the problem of the PSI pressure.
Pardon, sir?
They also have a problem of PSI pressure.
Okay. So we will help, sir. We will help him, sir.
Yeah. So put your question, Rafat, about the PSI.
Yeah, Rafat, sir.
Is it done? Is it uploaded? Okay. No, you need to now load it up. Now program the Arduino board with it.
What is the capacity of compressor you are using, sir? Rafat,
it's a 2 horsepower compressor.
2 horsepower. That's good. That's more than required. Fine. Okay. So this is 2 horsepower. 2 horsepower.
I think, Rafat, you will have to explain from the beginning because they were not there initially on the call. So I think you have to explain it from the problem you had.
Let me share with you a video.
Yeah.
Let me share with you a video. 1 second. Yeah. Okay. Let me do this.
Yeah. You can run your machine and show us.
Okay. So the machine is in the factory, so it's not here. But let me just do this.
Okay.
1 second.
Okay.
Sorry about this.
What is
let
this?
me 1 second. I'll show you 1 second. So this is the video. Let's share.
Okay.
So you can see here the two gauges. You see, it doesn't go all the way down.
Yeah. Okay.
And also, this is 30. So there is a calibration issue with this gauge of about 5 psi. So that means
Yeah, it
we
should
are
not
basically
go.
at 25.
Yeah, it should
And
not
then
go
if you
such
listen-
drastically.
Yeah.
It should go gradually. Is it going to zero or not?
It's not going to zero, no. But also, even it's not calibrated. It's not calibrated, so it doesn't go to zero. Period. So even if it's off, it stays at around 5 psi. So the left one, this one, the left one.
Okay.
The right one is calibrated, and you can see on the on the left one, you see it goes down to about 10, which basically means it goes down to about 15. And it doesn't load up all the way to 30, it loads up to 25. Yeah.
So you can do one
fine.
thing. You can do one thing. The right one you can interchange with the left one and then see how it behaves. Is it going to zero up to zero? The line pressure, running pressure comes to zero or not?
Okay. By the way, when we try to download the code onto the Arduino board, it showed an error. It did not download.
It's showing error?
Yeah, it says an error occurred on uploading. So,
okay. Oh, anyway, Suraj sir?
Yes.
You have got Rafat sir's number, no?
Yes.
We can ask Dr. Manu to help in this coding thing, and the pressure and all issues and the compressor issue and the outlet oxygen, these things we can help him with, isn't?
Yes, yeah. See, pressure I can also help him, but the PCB I'm not specialized, so we can take Manu sir help. He can also come in Zoom. Or we can have or we can have separate Zoom that also. But the separate or whether in this group doesn't make sense. That's fine.
The glorious player group, there we can do the thing.
Yeah. So just wait. I will share this link to Manu sir. He will let him come to this. Okay. 1 minute.
Have you spoken to him?
Okay, I will ask him. Just wait.
Yeah, please speak to him.
Pritpal is also here, so Pritpal can also put some insight.
Okay. Okay, Prit sir.
So in terms of switching the gauges, we have done that. We have switched the gauges. We have also switched even the pipes. We have switched also the we have also switched the the actual sieves. But yeah, you see the screen here. This is the error we are getting when we try to upload it.
Okay.
Hi everyone, Pritpal here. I'm just trying to get on a bigger screen. I'm working on my phone, so a bit not able to see it correctly. Just give me a few moments. We'll just reach out.
Okay.
Yeah, Rafat Pritpal also has a good knowledge, so he can also put in words. So we have a bigger team and bigger assessment. So let's see how things are.
Hello. Okay. And uploading the file. Okay, just one thing. Can you just raise the lower section where the error is coming?
Can you
something that the COM is not. You're not opening the COM gate, the communication line. Yeah. Just that lower section. Just raise it a little up. Yeah, exactly. Yeah. All right, that's fine. So, all right, your serial gate is not opened. So you need to do one thing, please. You just go to tools.
Okay. Go to tools.
Yeah.
Oh, you didn't. Welcome. 1 second. 1 second.
All right. Can you go to tools?
Yeah, 1 second.
Yep.
Okay, go to tools.
Now we need to check the serial monitor.
Now we need to check the serial. Yeah.
Monitor.
Serial monitor.
Yeah.
Yeah.
So I can't see the serial monitor running. We need to see that. All right. Okay. Okay. Just a moment. Okay. Okay. Board is not available at COM4. Okay. Go to the tools again.
Okay, go to tools.
Yep.
Go to tools again.
Tool. Yep. Okay. Port. No. Only the port. Tools. Then you go to the board. Tools. Port. Only port. Come down. Just to the port. To the port. Come down. Yeah. Just to the port. No. Yeah. Just yeah. Exactly. Okay. You have it COM3. Okay. You done it? Yeah. That's good. That's fine. Go to board info. Board info. Got board info. Yeah. It's just right there. Below. Just below. No. You're good. Get board info. Just click on get.
It's below the Arduino. Yeah, board info down. Next one.
Yeah.
Next one. Go. Yeah.
Okay. Now you're good to go. Now just upload the code.
So now we can download.
Yeah. Now do the load up. Okay.
Yeah. How to work.
It's being me.
It's done. It's already on. Uploading is good.
And Pritpal, can you check the timing also? They just modified.
Okay.
I'll just instead of 4 seconds, they did it to 6 seconds of production delay.
Yeah.
Because they were having this problem of the purity.
Yeah. Give me a moment, please.
Rafat, did it upload?
Yes.
Yes.
They can just run it. It'll be working fine as of now. The Arduino is good. The timings we need to just check it out.
Earlier they were having this 4,000 and the purity 25%.
Okay. Can we see the cylinders or the chambers first?
Just a second. I am going to the machine here.
They have 17 inches cylinders. The zeolite chambers, yeah.
Okay, the length is 17 inches and the diameter or the radius, anything?
It's the same which one is used. The sieves, the plastic piece, yeah.
Yeah, I think on that day, what I had a word with Daudi. So he was saying that we are having something around 3 inches. So
Yeah.
for 3 inches, we'll have to work out what exactly timings would work.
Yeah. I think you suggested
Okay.
18.5. I think.
Yeah, no, 18.5 is exactly what the original design was, which Meher has already made it, but it has to go a bit larger.
Yeah, but here they have been using 17 inches, so I think they are making,
So basically, we'll be just the output LPMs will be lower to the 17 inches.
yeah.
So
Yeah.
we need to go a bit higher for that.
Yeah, and they are also having problem about the PSI. So they have on one side they have some calibration issues. So the PSI is not going up. So they are having only 20, 25. It is not going up to 30. Yeah. Is it because of the sieve or it is because of the? It can be because of
sieves
something
effect. The sieves effect, because the lower the diameter of the sieve, you will face the challenges of drop in pressure. You will not be able to reach that pressure. So L to D ratio has to be maintained. So that ratio, we'll have to figure out what is the availability of the pipes, and then only we can have that.
So Rafat, can you explain which diameter of the pipe you're using?
I would have to go back to my colleague and ask him what they're using, but give me 1 second, okay? Let me just run and ask.
Yeah.
On the contrary, can we just show the machine as well, so that we can have a better look at it again, the whole circuit that we have made.
I think he has a video on the machine because he's sitting in the office.
All right.
So yeah, so he'll upload he will upload the video. I think. Yeah.
So this 10 millimeters. Can you hear me?
Yeah, I can hear you.
Okay, so it's 10 millimeters diameter and 17 inches high. Okay, sorry about that.
Just give me a moment. Something echo is coming. Right now you can go.
Still one more. No, we need more zeolites. Zeolite.
Hello. Okay, I can hear you now.
Hi. Prithpal, you're on?
Yes. Share something. Unshare it.
Use the O button.
Yes. Okay, let me share this here with you now. So we installed it. What's happening now? So you can see the left one. This is Steve A. So now it's going almost to 40, 45, and then it's coming down to about 15. And then on the second one, now going down to 0, almost. But it's going up to 20. I'm sorry, do you see what's happening here?
Pritpal, are you hearing?
Am I audible?
Yes, I can hear you.
Yeah, okay, fine. So the right one, from my perspective, where you're standing, the right one, if both gauges are okay, it's not, the swing is not happening in the right way. The swing is not equalized. So one of the cylinders is going way too up and the other one is not reaching up to that pressure. So what are the LPMs and the percentage, please?
So the percentage is 27% right now. And can you
27?
Yeah.
So it's 27%. All right. Okay. Okay. Got it. And what's the flow rate?
Flow rate?
Yeah. The liters per minute flow rate.
Yeah. On this one is 15.
Okay, it's 15. Just wait. Go back. Just to the flow rate. Okay. So this is wrong. This gauge is not to be used. It's for air. Don't use it, please. Use a special oxygen gauge. You're getting false readings here. So it's not 15 LPM. Yeah, this is not the right gauge. You need oxygen gauge. That is calibrated for air, not for oxygen. And it'll not be a good idea to go with this.
Okay. So
all right. So first of all, let's see where is the compressor. Can you please trace out where the compressor is? Yeah. I just need to see the compressor, please.
Just under 30.
No, that's the HP regulator. That's the regulator. You need the compressor, the pump.
The compressor where the air is coming from, Rafat.
Yeah.
The main unit.
Yeah. I think we lost their video. It's stuck.
You guys hear me, by the way?
Hi, Maher.
Hey guys, how y'all doing? We're cranking in here. And by the way, with there we go. We got his compressor back. If you can also share the specs on the LPM output at 2 bar at 30L.
Mayor, can you switch off your microphone so that Pritpal is actually helping them right now? Just listen to what. Yeah.
Got it.
Yeah, Rafat.
I think we have his video on another.
Yeah,
point,
he's got.
We're not having that.
Yeah, I think just wait because Afghanistan, those connections are sometimes slow. Yeah, now you've got.
We got it back. Yeah, got it.
Yeah.
Okay, please go ahead. Okay. Can we see the compressor, please?
Compressor they are using is 2 HP actually.
All right, that'll work. That'll absolutely work. For this setup, 2 HP is absolutely good. Okay, come down. The compressor. The pump. Oh, yeah. The pump. Yes. Okay. Now what you need to show me is the outlet of the pump. Where is the outlet? Pump outlet. I need to see whether the heads are connected or not. Okay. Got it. That's fine. Okay, from the pump, you are going directly to the coil. Wait. What's this hose going? Where is this hose? Okay, this is the copper connection, right? Got it. Okay, next we go to the copper coil, the outlet of the copper coil. The outlet. All right. Okay, that's fine. Go ahead. Now trace the pipe ahead to this is your regulator. Fine. Next, where is this pipe going? The outlet of the regulator?
Going down that.
Directly to the Y connection, right? Okay, makes sense. Okay, just need to see both of the walls, both the walls.
So there's one.
Okay, just show me the walls, please. Okay. So we have they look like, if I'm not wrong, they look smaller. These are quarter size walls. Can you show the part number on the walls, please? Okay, just wait. 3v3 10 10. That's fine. That's good. That's no problem. That's good. That should work. Okay, and it's an AirTech wall that'll work. Absolutely good. So going from the outlet, can you show the outlet of the wall? So that's directly connected to the cylinder. That's good. That's cool. So now all you need to do is the top gauges, the gauges on the top. Just go to the gauges on the top. Yeah. So these gauges, you have to work it out if they're not good. Do an exchange left or right and left. I just need to see whether their gauges are good or not. If the gauges are good, then I'll let you know how to troubleshoot them. Yeah.
Okay. So they're replacing.
Yeah. That's good. That's good. Yeah. Okay. Now just show me both the gauges, please. All right. Okay, you need to do one thing. You need to rotate the gauge number 1 that is on the left so that it makes sense.
Okay.
Just rotate it so that it is, yes. Yeah, just make them centered. Yeah, that's good. So we are going up to 30, 35. That's absolutely good. And this side.
It's not coming down all the way.
Yeah. So basically, okay. Can you mark this gauge with something? Something? Yeah. Can you mark something on the glass? Anything? Maybe a marker or something. We need to identify the gauge. Any soft marker. Just mark it as A and B.
A, B, 1, 2, whatever. Yeah.
Yeah, anything will work. That'll be fine. All right. Okay. So we have the gauge A. So A goes maximum. A max is 35, and A minimum is okay. That's the 35, and the minimum it goes to is 15. 15. It's not even purging 12. Okay, got it. And the B. Now let's see B. B is going minimum to around about 1 psi, 1 to 2 psi, and the max it goes to is it's 22, 23 psi. All right, now swap it again. Swap it again. Do you have more gauges, or they are the only gauges you have?
Yeah. No, we have more gauges.
All right. Let's check it out. Okay, now we have switched them over. Now in this cylinder, we need to see the B first. Okay, yeah, that's good. Okay, just power it up. Okay, the B max is again 22. And it's going to 0. So it's a gauge problem.
It's a gauge problem.
The problems are with the gauges.
Gauge B.
Yeah, they just replace both the gauges. They can't be verified independently, which is giving right or wrong. You need to replace both. Replace both the gauges with the fresh ones and give it a shot.
Hi, hi there, Karan here. Can I add something?
Okay, one more question. One more question. How much amount? What is the amount of zeolite that you used in there?
Çıkar zeolite para keren de acaba. 6 kilos para keren. Yeah, just under 3 kilos.
You use how much? 6 kilos?
Under 3 kilos. Under 3 kilos.
Under three, right? If I'm not wrong. Three.
Yeah, 3.
So you're
Yeah,
having
because it cannot take
sodium
more than that. No, 6.5 pounds. It must be around 6.5, 7
under
pounds.
3 kg of zeolite. All right, fine. So these are 17 inches of columns into 3 inches of diameter. Give me a moment, please. Huh?
Yeah.
I'll just have a quick calculation and let you know.
Hello.
Yeah, who's that?
Yes. Hi, this is Karan. Can I add something here?
Yeah, it'll be great.
Go ahead.
Can you show the equalization wall close up?
Equalization valve.
Yeah, yes. I have one doubt. I just want to make it clear.
It's on the top.
The
It's on the top.
equalization wall on the top.
Yeah.
Is it one way or two way?
One way or two way.
Is there any marking in and out, or if there is no marking in and out?
Okay.
You see that?
Yeah, I can see that. Basically, what happens is that normally whenever you buy these balls, they have a marking on that, and it gives a direction. So the whole point is I have used these directional walls, but they work fine, equally fine. I have a directional wall, it gives a direction in either direction, but they work absolutely fine. The reason is because they don't have any what you call that unidirectional pressure which actually elevates it. Anywhere the pressure comes and the poppet valve opens. It's that simple. So it will not affect you anytime. If whenever you want to use it, just put any direction, it will work fine. It works fine. No worries. But
Okay,
only and
what
only if
happened?
it has a go ahead.
Yes,
Please.
what happened in case of I had this experience here. We used one directional wall. So when the another sieve pressurizes, that just leaks out the air to the another. I guess there's some problem with this. I can see a pirate line from P2 that pushing it back, I guess. So if it's leaking out, it will not pressurize sieves properly. I guess this might be this problem.
That could be.
Yeah,
that could be
even I
the
think so. Even I think so. There is some problem like this.
That could be the
But the
case,
pressure is not
but,
supposed to rise so suddenly in one case and in one cylinder, and it's rising absolutely fine in case of another sieve. So I guess there's some leakage through this equalization wall.
as long as I'll just show you. Just give me a moment if I can just pull out the wall for you guys. I'll just show you the wall. It's only 2 ports. It's port that. How do I just show you guys? So give me a moment. I'll just come back to you guys.
Okay.
In the meantime, you can change the wall if you have it. That's absolutely good too.
You want us to change the equalization valve?
If you want to, you can give it a shot.
So first, should they change the regulator or they change also the wall?
Just give me a moment, please. Just go.
So we change the gauge. Should we start it and see what's going on?
Also, you can do one thing: just disconnect the pipe. Just disconnect the pipe and see whether it's holding the air while charging one sieve and vice versa.
Disconnect which pipe?
Which pipe they should disconnect?
Yeah, disconnect. Say, for example, disconnect the right one.
This one here?
Okay. Yeah, disconnect it. Okay. Okay.
Can you turn on?
Now
Turn it
see
off.
whether that is leaking or not. The wall. Yes, it's supposed to work for say 0.5, 450 millisecond only. Rest of the time it should not give any air out.
I think it might be giving air. Second, is it giving air out when it's moving?
Is it leaking continuously or it's a momentary blast?
Is it leaking continuously? No? Is there no leaking? There's no leaking. Ya quiere ver tiene que aguantar pues ya lighter. Na miche. Ya lighter ke? Vale? Ya lighter. Let's try with the lighter, see if there's any leak.
Now try the same thing with the opposite side.
Yes, just give me 1 second. First, we're trying to make sure that there's no leakage period. There is leakage.
All right. Who's doing that? Don't do it. Don't do it. Don't do it. Don't do it.
Don't.
Be careful. Don't do it. Cut
They're
out.
just
Time
checking.
out.
They will put it
No.
back. They will
Never do it again. Please. Just for the safety. I'm sorry to say. Don't do it again. Yeah. Please be safe.
We had this accident
All right.
over here. I burned myself very, very badly.
Yeah.
Don't
Okay.
never took fire.
I just wanted to show you guys.
Thanks for saving our life. Thanks for saving our life. So now,
Okay,
let's shift back to here and then try the other side and see if there's any leakage in both sides.
Hi guys, whoever suggests, please follow safety protocols.
Yes.
Don't suggest something which is dangerous.
Exactly. Be safe. Nobody uses anything of that sort, fires and all, please. All right, I have something to show you guys. Okay, that's your equalization valve. All right, so it says the direction. It says in and out. Okay, so in this is your solenoid. That's your solenoid, right? When you pull it out, that's your solenoid. All right, if you guys can see it nicely.
Right.
Okay, now it's visible. You can see two holes, right? So what happens is, this is your seat. This is called the seat. Okay, all it does is goes in and sits in there. All right. So can you see the center point?
Right.
The two holes. One is in the center. One is on the edge. I'm not able to do it nicely. Maybe something. Right. So there are two holes.
Yes. Clear.
Whatever happens is, whenever you give the current, it just pulls that solenoid up and both the orifices are connected. It doesn't matter if it is a direction in or is a direction out. No matter. Doesn't work like that. Because in other solenoids there is a special control line, pressure line that works in directional way. In this particular valve, no directions. Just pull the solenoid up and both the valves are connected. All right. Okay, let's see it again. Okay. Good. Very good. Good. So we have the problem again. So these are the new gauges, right? Okay, do one thing. Just do one thing. Can you get the Arduino code again? We need to decode it. Let's put the equalization down. We'll not equalize. Let's just check. Or just disconnect the equalization wall. That's absolutely fine. Disconnect the equalization valve.
Completely disconnected?
Electrical disconnection. You need to electrically disconnect it. You can do it either by the code or by just manually disconnecting the valve. Yeah, that's it. That's it. That's good. That's it. Now, let's see how it works. The valve is all closed all the way. It's not going to affect. Now let's see, do the gauges go up? Yeah. The valve must be closed now as of now. That's right. Just power it up. Now, I think that is sufficient. You already removed the solenoid. That's sufficient. No need to do anything else.
Yeah, but they had disconnected the Arduino board. So
oh, right. Fine, fine, fine. All right, just power it up. Let's see the pressures. All right. Okay. Going up, and going up. Okay. Going up, 25. And this number B is not going down 0. That is also not gone down to 0. Okay, 25. The problem is the columns, sir. It's the columns, The packing of the columns is not done rightly. One is compressed with more material and another is not having that much material. You need to weigh out the materials properly and then, yeah, both. Just do one thing, empty both the sieves, weigh them out before filling, and then you put them in. You can do it this way. Fill one column, and once you have filled that column, weigh it out. Once you have weighed it out, weigh exact amount on the other side, and then fill the columns. And one special thing is, when you are assembling the sieves, be very careful about the pressure plates and the springs. They should exert equal amount of pressure. Okay, so your filling has to be very carefully done. It basically tells me that both the sieves, they are not operating at equal materials, sieve beds. The sieve beds have varying pressure inside. It's not a problem with the, your...
You did not weigh the zeolite.
Yeah, the best thing is empty both the sieves. Empty both the sieves, refill one sieve with the exact amount and get the compression plate on top. And once you know this is my good volume that I has filled it, then you weigh that amount and put the same amount in the another one. Then should you be able to do the job again further. So the difference in pressure is basically due to the material filling in your tubes. It's imbalanced. It's not in balance.
Okay, we will do that and then we will get back in touch with you.
Yeah, that'll be fine. That's fine.
But
Rafa, tell them to follow the steps. What he's suggesting, do one first, weigh that, and then do the second one.
Yeah, yeah.
After you get the right pressure.
One more thing. At the moment when you do the fillings, even when you have done the weights also, measure the empty space on top of it when you have filled it. Take some kind of measuring tape or some scale or whatever. You need to measure the exact height that is available on top, right? Okay. And even before filling both the chambers, you need to ascertain both the chambers have equal space inside as well. It should not be that one of the chambers is smaller, another is bigger because of the assembly process. If that happens, even if you put equal amount of zeolite, you will get into trouble again. So the chamber space inside should be equal. Both the chambers should be identical, not outside, but inside as well. and
Should
then
they
that
try larger pieces?
Yeah.
Instead of 17. They try
I would
instead of
not
17?
suggest that. I would not suggest at the moment. They can do, but let's troubleshoot their initial design. If that works, we can go for a higher, bigger design as well. We just need to get 15 LPM at the rate 93% purity.
Okay.
Once the 15 LPM and 93 is verified, we can go 20 also, 25 also.
Yes.
Hello. Okay, so basically, we always make sure that first of all the inside interior dimensions of the seats are the same, and then make sure that we put the same amount of zeolite inside it, compact it, and then close it and weigh it, and then the second sieve make sure that we have exactly the same weight. Also measure the top distance, how much is empty, so that we have a double pickup on the content.
Yeah, you're absolutely right. You're absolutely right. So basically, it's just the interior volume should be absolutely identical. The interior weight of the material should be absolutely identical. If that is identical, we have equal distribution of material, then the pressure should not swing in that way. Then they should go down.
I think
Mr. Harshad wants to say something.
Harshad, you have to put on your microphone. It's not working.
There we go. Yeah. Okay. Sorry about that. I switched from my cell phone to my computer now. Back. Okay. I think we understand what we need to do. We will do it, and if we have still a problem, we will get back to you and ask for your help again.
Sounds good. Sounds good. Cheers to you guys. Good guys.
Well, thank you so much. We really do appreciate the situation in Kabul and Afghanistan is getting really bad with COVID now. And so about 50%, more than 50% of the people that get tested test positive. So, so this is getting really horrible. So they're in dire need of oxygen. So this is why we're very concerned that we need to get this going and then build more units.
Yeah, sure.
Thank you so much, everybody.
Thanks, Rafat, and we'll be in touch.
Thank you.
Yeah.
Take care. All the best, you guys.
I'll just check. Maher wants to add something. Maher, are you there somewhere?
So Maher is he's no longer in. Yeah.
Okay.
Yeah.
Okay. So anything else, guys?
Yeah, we have one little question.
Go ahead.
Yeah.
We are trying to build one 10 liter concentrator.
Yeah.
Yeah.
And our question is how much quantity of sieve beads will be required? If someone can guide us through. And also a type.
All right. Okay, you want a 10 LPM unit, right?
Yes.
Okay. 10 LPMs. First of all, have you selected what is the pump that you're going to use? Do you have the pump with you?
Yes, we got Thomas brand.
Okay, that's a brand. I just need the quantities, the pressure, and the flow rates.
144 LPM and 2 bar pressure.
144 LPM at 2 bar pressure. All right.
Yes.
Can you show the pump, please?
I'm sorry.
Can you show the pump? It looks small. I think it's a half HP pump.
One second.
It's either a half HP or a 0.75 HP pump.
Yeah, this one.
All right, that's a half HP. It looks like a half. If you can read that exact marking on there, it will be saying half HP, half horsepower. Yeah, you just have a look in there. It will be saying half a horse or half horsepower, 0.5 HP.
This is 70, I think.
Yeah, 0.75. Yeah, it's a 0.75 horsepower. So 10 liters from a 0.75 is not. I won't suggest it. You need a minimum of minimum 1 HP minimum. Basically, if you want to go for that. So for 0.575 HP, you are stuck at around about 7 LPM max.
Okay.
Yeah. So it's just basically directly going to the pump and saying if it's 1 HP, you go 1 LPM or 10 LPM around that. But you need to have a higher, bigger pump. That pump is only suited for 5 LPM derated. If we derate it, that's it.
Okay.
Maybe they can use 2 of these.
Okay. That's
Yeah.
good.
You can use 2 of them, but there is one issue, that is the synchronization of the pressures.
Yeah.
So that's
So
a real
we'll
challenge.
try to use 1 HP. Yeah.
You can get.
In fact, go bigger. 1
Yeah.
HP will be also less.
I think 1 HP or even 1.5 HP, whatever you guys can get hands on. Get a bigger pump because it'll solve a lot of your problems in the first go. Because a lot of people have problems with the pressures. They drop due to several reasons. So get a bigger pump.
Okay. Yeah. And zeolite, how much quantity we need to use that?
Okay. So for 10 LPM, you have these units, right? Okay. So can you let me know the ratios again, the length to diameter ratios? What is length? What is the diameter?
That also we want to know about the length and diameter. So right now we have 5 liter and we use diameter of 64 mm and
so
430 is the length.
Mm of diameter, right?
Yeah.
Inside
64.
or outer?
Inside is a 59 mm.
It's very small.
59 mm is around what? Roughly 60 mm is 6 centimeters.
Yeah, 60 mm. Yeah.
It translates to around about 2
length.
inches. 2.5 inches of 2.5 inches of diameter.
Yeah.
So 2.5 inches of diameter. You want, what are you looking at? You want 10 LPM out of that?
No, this is we have done for 5 liter. So we want to know what will be required, the diameter and the length and the material quantity.
See, we need to first figure it out. That have you used the compression springs in there?
Yeah, compression spring we have used.
Okay, what is the pressure that the compression spring exert? How much pressure do they exert?
Exactly.
All right. Okay. You can see that. Okay. Have you used exactly this?
8 mm diameter of the wire, steel wire.
Yeah, got it. I can see that. That's a bigger. Yeah. So the point is, how much compression? How much are you compressing this spring? Is it a 1 inch compression? Is it a 2 inch compression? How much are you compressing it out?
Yeah. One inch we have compressed it.
Yeah.
Right now.
So if it is a 1 inch compression, can you know what is the load on there?
That I have not checked, but I have to check.
Okay, no worries, but you should do it. Just take a weighing scale, just compress the spring by 1 inch and check what is the weight coming on the scale. You'll know what is the loading. Okay, once you have that, yeah. And secondly, the diameters. Everyone is using very small diameters. They are going to cause real trouble for the long run because the pressure will be too much in these smaller chambers. You need some bigger chambers. Get some bigger chambers.
Yeah.
At least get some 3.5, 3.5 if you're looking at 10 LPM.
Okay.
So
3.5 mm.
No. It's 3 inches of ID in inner dia.
Okay.
Yeah.
3 inches
3 to
ID.
3.5. Going in shorter diameters is going to have a real trouble for the pump to pump it all the way up and maintain those pressures. So the timings, that's why the timings are not working for everyone. That's a reason.
Okay.
Yeah.
So and what is required, the quantity of the
All right. See, it's basically depends upon the source of zeolite that you have, right? All zeolites are not equal.
Okay.
That's the whole thing. So whenever anybody asks this question, what is the quantity of zeolite? Straight away, you can't answer accurately honestly. The zeolite must have some specifications. Okay. What is the make?
Make I have to see.
What is the make? Is this from AGC Chemicals?
Yeah.
So it's Jalon.
Jalon, yeah, exactly.
Yeah,
This
it's Jalon.
This is
Yeah, got it. So is it a sodium?
This is lithium.
All right. Okay. You guys got lithium as well. That's half kg thing, I think so.
Yeah, half kg. I have a 5 kg total quantity right now.
Of this lithium, right? So lithium
lithium
is
5 kg
yeah.
and 25 kg is sodium.
Okay, that makes sense. So you have this. So Jalon is good to go, sir. So what you need to do is, what is the bead size? Is it 0.4 to 0.6?
0.4 to 0.6.
Okay, that's good. That's good. So all you need to do is, I'll just let you know for 10 LPM what do you need. If you're going to use sodium, the calculations might differ. I'm using lithium as of now. So just give me a moment. I'll just figure it out. Yeah. I'll just come back to you on the calculations part. It'll take time because yeah, no worries on that. So the good idea is that you guys take some bigger volumes. So and then you fill it up, right? So higher LPMs are not bad. That's the basic line, underline. Higher LPMs are never bad. Don't target that we're going to 10, target it maybe 15 also. Get bigger chambers and we'll fill them up to our desired ratios, whatever we want.
Yeah.
Yeah, makes sense. Okay, guys, any more questions, please?
No, sir.
All right.
Hello.
Yeah.
Hi, Britpal.
Yeah, please go ahead. Hi.
Yeah, hi, Karan here. Can you help me a
Yeah.
bit? I'll just turn on my video.
Yeah, sure, please.
Yeah, this is my machine.
Okay.
Okay. What I use is one compressor is 1.5, 2 HP. One is 1 HP.
Wait. One is 2 HP. Which one is 2 HP? Which one is 2 HP?
This one says 1500 watt.
Which one? This one? 1500. Yeah. Oh, right. Now I can see it better. Okay. Okay, makes sense. So that's a 1500. Okay, just let me pin your video. Just give me a moment. Let me pin your video. Okay, I can see that now. So that says 1500. I can't read it exactly. I'm not able to read it.
BT750. I guess this is
okay.
1.5 HP over here. See that?
That's absolutely fine. If it's 1.5 HP, all I need to know is what is the LPM at 8 bar pressure.
At 8 bar, it's 120 LPM.
120?
120 LPM.
120 LPM at 8 bars. That's maybe overrated. That's overrated. That's overrated. Normally, if it's a 1.5 HP pump, maintaining 8 bar and 120 LPM, it's not a joke. 2 HP pump that we do normally use, that delivers around 100 LPM at the rate of 8 bar. So maintaining that high pressure, it's good if the manufacturer has made it, but just make sure that it does provide that much of LPM. Okay. So you have 1.5 HP one pump. Another pump is?
That is 1 HP.
Okay, the
now,
1
as
HP.
As per this model, that one is 1 HP.
Okay, go ahead.
Okay. After that, everything is hooked up. I'm using lithium from Bchem.
Yeah.
That's
Okay,
around
beacons. So
1200
fine.
grams. Yeah, 1200 grams in this canister, 1200 in this canister.
Fine,
Now, right
fine.
now at 5 LTI, I'm getting around 90% of concentration.
Okay, okay. Just a moment. Just hold on. Are your pressures good? Your swing is good?
This is the output pressure, max 30 psi.
That is your working pressure, right? That is from the compressor, if I'm not
That's
wrong.
not regulated. That's the maximum pressure I can get after hooking up both the compressors.
So can you show me the cooling coil? Okay, okay, that's your cooling coil. How many turns is put many? Is a 3/8 cooling coil?
3/8, yes.
Okay, why is there a T over there on top of that?
I didn't got the coupler, so I just hooked up a T and started the same.
No, have you closed the T on top?
Yes, I closed it.
Okay, that's fine. That's fine. Makes sense. Okay, from the that. Okay, well, just a moment. Just a moment. From the compressor, when we go up, first we have the regulator, right?
Right.
So the compressors are directly connected to the regulator. Okay, okay. No good, no good, no good. Time out, time out. Time out. Okay, just switch it down. So first of all, we don't need to connect. No, I'm just one question. This regulator, is it connected at the end of the coil or before the coil?
At the end of the coil.
All right, then it's good. Then it's fine. So the compressor supplying to the coil, cooled, and then regulated, then going to your sieve beds. Okay, next. Yeah, next. Go ahead, please.
So that this is the water. So I guess this one is working. After that, I have hooked up these two silica gel canisters.
Okay, just show those canisters. Just show the canisters. Okay. So are these canisters in series?
In series.
No, they won't work. Sorry, brother, they won't work.
Okay,
they will work, but they'll saturate, and you're out of luck. Then when they saturate, you'll be basically it'll be creating more pressure down the line, pressure drop. So you are actually the compression and that totally we will be loading the compressors. So they're not to be used. I've used them. I've tried them. Series is not the answer.
Okay.
Inline is not the answer. Series is, but there is a different part to that. Yeah.
Okay, fine.
So absolutely, but what you're doing, I'll just brief you on this bit. So these compressors have a certain volume, maybe 1 liter or 2 liter.
This one, I guess 1 liter.
Maybe 1 liter. All right. So whatever we are doing is we are filling these canisters as well. So we are basically taking compressor capacity and dumping into these two chambers. So we are just eating out the capacity that has to go to the zeolite chambers, right? So it's not good thing to use in series. Just make sure that you have some alternate design for that.
Okay, I read one alternative about this, that using activated alumina. So now this is my first prototype.
That's another point, my brother. You can use activated alumina, you can use silica gel. Both will be working fine, good. They only have the difference in what amount of ratios they can absorb or not. The whole point is, if you want to use them, you want to use them at heatless dryers. So heatless dryers, in your case, it will be tough to achieve since the compression and the air volumes are low. They can be used in heatless dryers, but not this way. This way, if you use them, we simply, you can understand that. Once you are putting all the compressed air, it is going through, they will absorb. But where will the moisture go once they are completely saturated? They'll be loading the pumps.
Exactly.
So that is the question.
One article about that.
Yeah.
So this is my second attempt. I will just show it to you.
Okay.
I built this canister. This is 4-inch. Okay.
Hello.
What I thought is this much of with activated alumina and remaining with flux. Every time you then do that, it will get regenerated. So is this approach going to work or not? I just need that opinion.
your video just got lost. Can you come back again, please?
1 second. My video on.
Yeah, I can see that now. Now go ahead, please.
Okay, you can see the canister. Okay. So what I thought is filling up around 20% of the volume with activated alumina and remaining with the zeolite. So every time I charge and discharge, it will
Yeah, good choice, brother. That's a good choice.
Is that a good approach?
That's a good option. That's a good option. Yeah, go ahead.
Okay,
that's a good option.
Great. And another thing, what I did is, I just want to share, I used schedule 84 inches pipe and just threaded over here and threaded in the inner side. So that makes
totally your call, brother. I'm not good with plastics. I use only metals. So no calls on that. I wouldn't suggest something which is going to have safety issues in the down the line. Safety is a big concern here.
Okay. And in case of alumina, that's a good option as per your opinion. That filling up half with alumina and half with the zeolite.
Yeah, that's a cool choice. That's a cool choice.
Okay. And one more thing. It's a cooling coil code refrigerator.
So you guys from Hyderabad?
No, I'm from Pune.
Pune, okay.
Yes.
That's good.
And one more thing. We are just rearranging our workshop. It's a bit messy over here.
Okay.
So what I was going to try next is, instead of cooling coil, I was going to use this one.
All right. Okay. A good choice, but then you have to make sure all right. You have to make sure there's all these coils, whatever you want to use a cooling solution. Every time it's just like electrical circuit. Whenever you add something, you need to check how much current drop is going there. So these cooling coils, they will work good for cooling, but at the end of the day, if you're getting too much pressure drops, no good. So you have to be very careful selecting these. These are to be just as needed.
Okay, great.
Okay.
Now this comes with 10 mm pipe.
Yeah.
So we'll just
That's good. That's good. And why these are the serpentine coolers. So basically they run in line and they work good. They're absolutely good choice. But the whole thing is, if you're going for a smaller system and you're putting a bigger cooler in there, you are losing your pressures.
Right.
So it's basically you have one battery, that's your pump, and you are putting all the filters in front of it, and the end load is going to get choked. It will not get the supply it wants. So the entire idea is do whatever you want, but your sieves must see a pressure of at least 40 psi.
At least 40 psi. Okay.
At least 40 psi pressures must be there at your sieves, at the inlet of your sieves. If you're going there, it's good.
In case of lithium.
Do whatever. You put an elephant, you put a horse, whatever you want to, but you must have 40 psi at inlet. It's completely your choice. Whatever you want to put good for your designing, go ahead. But have 40 psi there. So as long as that criteria works, you're good to go.
Karan, you have to listen to Prithpal because Prithpal has done 28 liters with 95%. So he has a lot of experience.
Exactly. That's why I'm asking every whatever doubt I have with him.
Yeah. So Prithpal is very experienced, and I've been listening to him for the last 1 hour almost, and he's advised very good to Rafat, and so he understands the machine in and out, and also the other parts and Arduino and all the software. So what advice he gives, just follow that. I think you will be successful.
Sure, sir. Thank you so much. Thanks a lot for that advice.
Yeah.
You're welcome. That's all from my side. Thank you so much.
All right. Yeah. Good. It's nice to see you guys. Thank you.
Thank you, sir. Thank you.
Yeah.
Sir, this is Arshad.
Yes, Arshad.
Yeah, can I show me my machine, sir? Is it working right now?
Go ahead. Prithpal, are you there still? No?
I'm here, sir.
Yeah.
And this is the purity.
Can't see your machine. I have to pin you down. Maybe I've pinned the current for that moment. Just a moment.
96.3%. It said what liter? 5 liters.
Can you give your name again, please?
Harshad Patel. Harshad.
Harshad, all right. Where is Harshad? I can't see him, Harshad. Okay, here it is. Yeah, I got it. Go ahead, please.
Yeah, Harshad, go ahead. Show the video again. Yeah.
So now we want to make a 10 liter. That's why we are.
No, first show him the purity now. What you're getting for 5 liters. Show him again. Pritpal is now on your video. Yeah.
All right. So that's a 96.5. Okay. Just hold on. Okay, now what you need to do is, can you show me the liters per minute, please?
1 minute.
Yeah. All right, just hold on a moment. Just show me the gauge first. What gauge are you using? I need to see the gauge bottom where it is written calibrated for what. We need to see what is the gauge calibrated for. Is it air? Is it carbon dioxide? Is it argon?
This is air only.
Okay. It's no good. You need to use something for oxygen.
So when we buy from this guy, this is for oxygen only, and we
No. This will give false readings everywhere. So the good thing is, I'm going to make a few these mass flow meters myself in the coming days, and we'll be sharing with them to everyone. Whosoever wants it, you can have them. So round expecting a cost of around nothing short of 25-30K. So, but those will work. The commercial ones, they come up to maybe 70 or something like that. So I'm doing something in-house so that we can share it with everyone. Yeah. So one thing is very critical. If the percentages are good, and that is the good thing you're having, but the LPMs, you should always see it on an oxygen gauge. We cannot use anything else. That's right now my dilemma. That's right now my choice. Yeah. So one thing you can do, just increase the LPMs, please.
When we increase that, purities go down.
No, I'll tell you. Okay. Have someone there on the purity meter, and just decrease it only until you see a fall.
Okay.
Okay. Can you do that? Take the meter with you. Yeah. Take someone and ask him to just check it while you increase the flow rates. And just stop when you see there is a fall.
Okay, 1 minute.
Yeah. Okay, you're going 97, your LPMs are higher. You have already derated your LPMs. Open it very slowly, very slowly. Don't go fast. Okay, stop. Okay. So the idea is we should not go below 93%. Okay, close it again. We need to reach 93%. We need to reach 93% again. Close the valve so much. We need to reach 93%. Harshad, I think you are from Ahmedabad, right? Which place, Surat?
Yeah, I'm from Gandhinagar.
Gandhinagar, oh good. I was in Ahmedabad.
Oh, very good.
Yeah. No, not right now. Right now I'm in Gurgaon. Yeah. Just raise it to 93%, and whenever it reaches 93%, and then adjust slightly more to go 94. Check both the readings.
Okay. Bas.
Okay. When you reach 93%, note down the LPMs. Be very slow. Yeah. So when you reach there, and then you have your good numbers. That what is this? Right.
5 ऊपर लाइए. चुप रहिए बच्चों के
Yeah, it's 94. It's 86.
All right, you guys are reaching around about 93%. Note down the LPMs when you reach 93, and again note it down when you reach 94. So when you reach 93, that is your bottom line. Those should never be exceeded. Don't raise any LPMs beyond that. Okay, that's your bottom line. So you should derate it to 94%. So when you are going for any specifications or anything like that, go for 94% and then claim it. It's plus minus this and that. That's good to go.
This is our first trial, sir.
That's cool. That's cool.
LPM, sir.
Yeah.
This is a 5 LPM only.
There are no problems. Everybody starts from there, and then onwards you can build it up to your requirements. We started at 33% purity at the rate of maybe 35 or 40 LPM when we didn't understand the system much, but that was 3 months back.
So if we want to make a 10 LPM, then we have select compressor for 1.5.
First of all, for a 10 LPM, the minimum requirement of air would be 1 plus HP. I would suggest go for 1.5 HP pump, not even 1 HP. Go for 1.5 HP because 0.5 HP will be doing some kind of drops, maybe compression in the coil, maybe that's filters going through. So you're already losing some of the power in there. So what you need to do is you need to provide 40 PSI at the gates of the sieves. So if 40 PSI is coming at the gates, your design is good on the air side. You need to design your air side keeping in mind that 40 PSI is always delivered at any cost, not below that.
Okay. You like how much quantity we need to use for that 10 LPM?
It's a sodium. I've already said I'll have to come back with the calculations. I could achieve, I will not quote it actually because the reason is my LPMs were not good at that time. But anyways, you can go around about 1 kg each, 1.5 kg each. I'm not sure of it. I'll not quote it, but it's better that I'll come back with some real numbers. Okay. Yep.
And what do you suggest your diameter of the pipe?
the original design of the OxiKit is 18.5. I'll just let you know, it's L2D ratios. So the original design of what OxiKit has done is 18.5 is the length of the columns, zeolite columns, and 3.5 inches is the diameter. So these are the basics, and you should always multiply with this. These are your basics.
Okay. So we'll try, and if we get any problem, we'll come back to you. Okay.
Any more questions, please?
I think they are good to go.
All right, that's good.
Anybody has questions? Otherwise, we close this session.
I think people are working on the system. Yeah.
Okay. Do you think that 4-inch sieve should be better than the 3-inch which we are using?
Yeah, that's what I talked to Meher on that day, that we need to go for 4 inches. 3 inches for higher LPMs is no good. It's going to load the compressor a lot and the outputs will be low. We need to go higher, at least 4 inches minimum. But the point is that all the heads, everything, whatever they use, the materials that are already in, it's a bit of a tough game going and getting 20 plus with them as of now. Since you do have a higher compressor.
Not a problem because we already have the aluminum pipes because we use it for soccer goals and stuff.
Great.
4 inches.
Yeah, we can do that. We can do that. You have bigger pumps. That's your good thing with you. That you have a bigger pumps. That's 2.5 HP. They're going to help a lot, and that is one positive side of the things. But again, the design part of this has to be done. Maybe it will take more 2 to 3 days to just close it up.
Yeah, because we can parallelly do that. No, we can keep trying 3 inches and 4 inches because Ed was suggesting that we should keep one size. So for the smaller machine, it will also work. And then for the bigger machine, you can have one more sieve. But what I understand from you is that air pressure maintenance is better if you use a larger sieve.
Yeah, because the point is, if you have narrower sieves, what happens is the pressure differential pressure differentials is a trouble. Yeah.
And then for 4 inches, then we need pressure, like the ends to be stronger.
I'd suggest you a few more things that we can use. We can just catch up and sit and work on that.
Sure.
There are a few things that are far better in choice than using any of the things that we are currently doing. That will be cutting our costs on manufacturing and everything. We can sit down and we can have a word on that.
Yeah, sure. Let's have a chat separately.
Sure, please, sure. That'll be great.
I think we can close the session now, or should I wait first?
Yeah, I think we'll be good to go now, since everybody is content with what they have.
Yeah.
Okay. Nice meeting everyone. Thank you, everyone.
Thanks, Mitchell.
Thank you so much.
Thank you, sir. Thanks, everyone. Thank you.
Bye-bye.
Thank you.
Good day.
Bye.